last time. We're just going over our basic linear equation. We looked at this example and then we looked at those properties for equality. We had done equation 1 and we were working on equation 2. Was anybody able to come up with an answer for equation 2?
Yeah.
Yeah, what did you get?
-6.
-6. You got +6. Okay. Anybody else have a different answer than those two? -6 or +6? Or did we start the problem but were not able to complete it? Did anybody run into that? Yeah, how far did you guys get?
Where we left off in class.
But you didn't try,
I did try.
you were not able to?
I just was unsure, like exactly what steps to take next.
Okay. Okay, who else had trouble?
I did, but we worked it out,
You worked it out?
and we got -6 too.
Okay. You got -6 or +6?
I'm gonna have to do it over again because it was we're in the other class a little bit ago.
Oh,
I
okay.
actually did it wrong, and she asked me for help. I had to change that because I actually didn't create a common denominator for the piece of paper. So
Oh, you didn't do a common denominator. That will give you trouble.
And I got a 7, which was incorrect.
Yeah. But did you go back and put it back into the equation to see if it would work? Or no? Like, you know, the check step we had done.
So, it was funny because she ended up getting a 7 too.
Okay.
She did. I didn't even do that, and I just started doing the rest of the packet. So
Okay. What did you come up with?
I didn't finish it.
You didn't finish it? Oh, okay. All right, so let me see really quickly what you got. Okay. We multiply this with the 3. Is that what you did?
So I figured out 6.
Common denominator. Okay, so you multiply everything by 6.
Find everything by 6.
Okay, and that's where you got the 3x from. That's a 30. That's a -73, and that's 2, so 4x. Okay. Okay. So yeah, -6 actually should be the answer for that one. So let's go ahead and take a look at what we get from here. So I'm actually using, I don't know, I don't think any of you were in my other class last semester. So, except you, right? You were in the night class. So yeah, I'm actually going to be recording these lectures that we do in class and posting them on D2L. So the idea is if you, oh, there you are, Oscar. If you miss class for any reason, you can go and look at the lecture on D2L. Or if you just needed to go back and look at an explanation for a problem, you can do that, okay? Alrighty, so starting with our problem number 2 here. Oh. Okay, so pretty much what we had done last time was just clean up our problem a little bit. We had x over 2 minus 5 equals -12 minus 2x over 3. So the first thing we had done is get our like terms on the same side. So we ended up, I believe we had moved the 5 to the other side and brought the 2x over 3 to the left-hand side. So your, sorry, these guys cancel out. These guys will add up. And that will give us 2x over 3 plus x over 2 here. This one ended up giving us, what was that, -7. And is this where we left off last time? Okay, you obviously just went to the original problem and tried to simplify it, right?
Right.
So you did it a little bit differently. Now again, remember the thing about math is you have multiple different approaches on solving a problem. I'm showing you one way, but maybe you've seen it done a different way. So at this point, we basically combined our constant terms, negative 12 and positive 5. We've got our x terms on the same side of the equation. Now the idea is, obviously you can see they have two different denominators, so we need to be able to find a common denominator. So since 3 and 2 cannot be broken down any further, basically just go ahead and multiply those two numbers together and you get your least common denominator. So that will be 3 times 2, which of course ends up giving us 6. So to be able to turn this into a common denominator, you can either multiply the first fraction by 2, multiply the second fraction by 3, and get that common denominator. Or we're actually going to do what you did, which is actually get rid of our denominators completely. So instead of just finding a common denominator, take this least common denominator and multiply the entire equation by that number. So what happens is it actually helps you get rid of any denominators, and then you get a nice clean integers to work with. So we're going to take this number 6 and basically multiply our entire equation by that. So each term has to be multiplied by this 6. Okay, so that will end up giving us 6 times 2x over 3 plus 6 times x over 2 equals 6 times negative 7. Make sure each term is getting multiplied by that number. So what do you think is going to happen on the first term when we multiply 6 with 2x over 3? Normally, what would you do? Do you multiply across or do you try to reduce your number? Yeah, that's what I normally do, is reduce my numbers. But if you want to multiply 6 times 2 and then divide by 3, you can do that also. I'm going to actually just cancel them out. So 3 goes into 6 2 times, right? So just reducing my numbers. 2 will go into 6 how many times? 3, yeah. So go ahead and clean those up. 2 times 2 will give us 4x plus 3 times 1, of course, will give you 3x equals 6 times negative 7. Negative 42. Yeah. Alrighty. And you can kind of see how that leads us to our answer. Combine like terms, so 4x plus 3x will give you 7x. Divide both sides by 7 to get that x by itself. And we end up getting x equals -6. What did you guys do? Did you, were you guys kind of working the same way?
And we actually did the common denominator way.
Common denominator. So you took the original.
Yep, we took positive 2x by 3 and x over 2.
Okay.
And we created common denominator as 6. And then from 6, after we did 4x over 6 and 3x over 6,
Ah, okay.
that broke down to 7x over 6. And then from 7x over 6, 7x. So,
Yeah.
yeah.
And then you basically moved it to the other side to get your x by itself. Okay, I see what you did. All right. Now remember what I had told you. It's always a good practice to check your answer in the original equation just to make sure that the answer we came up with actually does work for our equation here. So we'll go back to our original, which was x over 2 minus 5 equals minus 12 minus 2x over 3. And everywhere you see an x, replace it with that negative 6. So basically we'll end up getting negative 6 over 2 here, minus 5 equals negative 12 minus 2 times, again replace your x with negative 6 over 3, okay? Clean it up. So 2 goes again into 6 3 times, so that will become negative 3 minus 5. Negative 12. Since I have two negative signs here, negative and negative will become positive. 6 times 2 is 12. 12 divided by 3 will basically become 4, right? Okay, and then just add both sides of your equation and make sure you're getting the same number. So this will give us -8. This will also give us -8. And that's what you're looking for when you check to get that true statement. If you don't get the same number on either side, then the x value obviously is incorrect, right? Which means we need to go back and do our math. Okay, so can we go back that way for 1 minute?
Sorry, what is it? Thank you.
No, you're fine. All right, while she's writing that down, let me see what you guys can do for number 3. There are no fractions in that. So hopefully you can come up with something on your own. You already have that done? So what's the first thing, what's the first thing you will do when you're trying to solve problem number 3?
Take care of the units.
Sorry?
Take care of the parentheses.
Okay, so what would we need to do for that?
Take 5 times 3x, so that's gonna be 15x. You're gonna take 5 times -2.
Yeah, so you're talking about the distributive property, right? Okay, very good. And then what do you guys think happens on the right-hand side? Same thing? Anybody tempted to do 5 minus 7 first? So you cannot do that because remember, the idea is you're following order of operations here. So you can see it's 7 and then parentheses x minus 1, right? Which means that's multiplication and this is subtraction. And we know from, please excuse my dear Aunt Sally, we always multiply before we subtract. So that's why you actually need to take the 7, distribute it inside the parentheses. And once you get rid of the parentheses, then you can do the 5 minus and then whatever numbers you get after that. All right, so let's go ahead. And put that. So as long as you keep track of your signs and follow your math, you should be able to solve this. So again, start with that distribution. So we will multiply the 5 inside the parentheses and the 7 inside the parentheses. So 15x minus 10, right? 5 times 3 is 15, 5 times 2 is 10, equals 5 minus, and then we're multiplying 7 times x. If you want to think about it as multiplying -7 times x, you can do that also. So that will be -7 times x, which is -7x. -7 times -1, 2 negatives will make it a positive, and you'll get a positive 7. It actually makes sense to take the sign with your number, because in this case, as you saw, the 2 negatives will change the sign and make it a positive. So it really helps to think of that as a -7 instead of 5 minus 7 when you do the distribution part. Okay? Now it's just about combining our like terms. So of course, on the right-hand side, we can combine the +5 with the +7. So we'll go ahead and do that first, which will become 12 minus 7x. And then bring your terms on the same side. So what do we want to move? The x or the constant? Want to move the x? So move the 15x or the 7x? Want to move the 7x? Okay, so since it's minus, when you're moving it, it will become plus. So that's positive 7x. And these guys cancel out. 15 plus 7.
2x.
Yeah, very good. 22x. And then, of course, we want to go ahead and add that 10 to the other side now. So that will end up giving us 12 plus 10, which is also 22, right? So x equals
1.
1. Yeah, very good. And we'll do a quick jump over here. So obviously inside the parentheses, 1 minus 1 will become 0, and 7 times 0 will be 0. So you get left behind with just a 5 on this side. 3 times 1 is 3, so that's 3 minus 2, which will be 1, and then of course 5 times 1 is 5, right? So then a true statement, which tells us our solution is 1 in this case. Okay, questions on solving these equations? Okay, now depending on, we can classify our equations into different types of equations. So is it an identity? Is it a conditional equation, or basically is it an inconsistent equation? And that actually depends on what kind of solutions these equations will have. So as you can see by definition, we're saying an identity is an equation that is satisfied by every real number for which both sides are defined. So if you look at these examples that I have up here, 2x minus x, when I simplify that side, what do I end up getting? 2x minus x.
2x.
1x, right? Because you're taking 2x, you're subtracting 1x from it, so 2 minus 1 gives you 1, right? So you're going to have an x left behind. You can see you're actually going to end up with an equation that is x equals x. That's what makes this an identity, because whatever solution I put on the left-hand side will be the same thing for the right-hand side. So basically my left-hand side is equal to my right-hand side. Look at this guy here, same term, right? 3x minus 1, 3x minus 1. So my left-hand side is exactly the same as my right-hand side. So whatever solution I put in here, I'm always going to get that true statement no matter what. What happens when I simplify this one here, x divided by x?
X.
1, right? So you will end up getting 1 equals 1 on this side. So basically with an identity equation, that's always what happens, is your left-hand side will end up looking exactly like your right-hand side. So whatever value we put in for our x is going to be the same. So let's just look at that first example of 2x minus x equals x. So let's say if I want to use, we'll just keep it simple, x as 1, right? So if I plug that into this equation, I will have 2 times 1 minus 1 equals 1. 2 times 1 is 2. 2 minus 1 is 1. I get the same value on both sides, right? All right. How about if we use x equals negative 3? Okay, so again, plug that into your equation. 2 times negative 3 minus, again, for x, it's negative 3, and x is negative 3. So in this case, when I multiply, 2 times negative 3 will give me negative 6. Negative times negative will become positive, so that becomes a positive 3. What's negative 6 plus 3? Negative 3. Right? Same value on both sides. So that's what makes this an identity, because you're always going to end up getting the same value for both sides of your equation. But if we go back and look at our last equation, the only exception here is going to be, since in the original equation I have x in the denominator, anytime your variable ends up in the denominator, you're always going to have at least one number which you cannot include in your solution set, because that's the number which makes your denominator 0. In this case, if x was 0, you're basically ending up with a situation which is 0 divided by 0. So if you have your calculator out, go ahead and type in 0 divided by 0. What does your calculator tell you? Error? Yeah, because 0 divided by 0 is not part of the real number set. You're not going to get an answer. Division by 0, just in general, is undefined. Okay, so that's something we always need to remember, that anytime we divide by 0, you're going to get undefined. But when you say 0 divided by 0, it's actually indeterminate. Because if you guys get to a calculus class, you will talk a little bit about it because they'll get into limits and those kind of discussions with it. But for now, division by 0 is undefined and 0 divided by 0 is indeterminate. Okay, so that's the reason why when we look at the solution set for this last equation, you can actually use all real numbers as part of your solution, except you cannot use 0 as part of the answer set. But for these other two examples, your solution set will actually be all real numbers because you can use any x value and you will still be able to get a true statement out of this, with the exception of that last one. Now your conditional equation, again, as the definition goes, is an equation that is satisfied by at least one real number, but it is not an identity, which means in an identity, I can use anything for x and it will work, right? In a conditional equation, we're basically saying it's not an identity, which means you just cannot throw any number in and expect it to work, but you should have at least one real number as part of your solution. So the examples that we did in 1, 2, and 3 are actually your conditional equations, because we, like you guys said, you got 7 as the answer, but that didn't work, right? So that's the idea, that you just cannot throw any number in there and expect it to work. Conditional means you should have at least one answer. You can have more than one depending on the type of equation. So in these guys, if you try to solve 2x minus 6 equals 8, you're going to get what? We add that 6 to the other side, which will give us 8 plus 6, 14 divided by 2, 7, right? So basically, this equation here is only going to have one solution, which is going to be x equals 7. Okay, so that's the conditional, that it's basically going to satisfy one answer, but none of the others. Inconsistent, as the name goes, basically means it's an equation that has no solution. So here, what's going to happen if I try to bring my x on the same side? They will cancel out, yeah, because you're going to do, let's say we move this guy, so we do minus 5x. Minus 5x and 5x will cancel each other out. Your x has basically disappeared. What's happening when we do 0 times x? 0, which means he's gone, and now you're getting 1 equals 2, right? Same thing's actually going to happen here. So let's take a quick look at that example. So this one was x plus 3 equals x plus 5. So we can start by moving the 3 to the other side. These guys cancel out. That x equals x plus 2, right? Kind of like that 5x example for the first one. Now, if I try to bring my x's on the same side, let's say we're moving him, so that's going to be minus x. Well, positive x, negative x cancel out, and same thing's going to happen on the left-hand side. Positive x and negative x cancel each other out, and you're basically left with 0 equals 2, which is a false statement, right? It should either be 0 equals 0, 2 equals 2. So for inconsistent equations, that's what happens. You end up getting a false statement for any, any x value you put in, but also for when you solve these equations, you will notice that all of these are going to end up giving you a false statement. So since they have no solution, it makes it inconsistent. If we can use all real numbers, it's going to be true for any value of x. It's an identity. And then if you're only able to use 1 or 2 values, not more than that, that's when the conditional comes in, because you cannot just put any x value and hope for it to work. So identity, conditional, inconsistent, and that's what you guys are trying to identify in 4, 5, and 6. So let me see what answers you come up with for those. So the idea is try to solve them, try to get your x by itself, and see, are you getting a true statement, a false statement, or do you actually get an answer for x?
Can X be 0?
Yeah, that's an answer.
Okay.
Sure. So if you get x equals 0, technically that means you should have a conditional equation.
I know you mentioned get X by itself, but number 4 after equal to itself, it equal to itself before it even got to that. You have to get to nothing. So
Okay, so what was your
identity.
identity? Okay.
Yeah.
Alrighty. So as soon as you basically distributed, you saw what happened, right? Yeah. So start by taking that 3 and multiplying it inside your parentheses. So 3 times x is 3x, 3 times -6 is -18. So, I mean, right at this stage, yes, you can notice that I have 3x minus 18 and 3x minus 18. So if both sides of your equation are going to be the same thing, that definitely leads to an identity. But if you just want to go further, you can start by adding that 18, which will of course cancel out on both sides. If we try moving that 3x, same thing is going to cancel out on both sides, which will actually end up giving you 0 equals 0, which is a true statement, and that leads you to an identity. But if you want to stop at 3x minus 18 equals 3x minus 18, that's fine, okay? All right, very good. So 4 was identity. Yes?
I put x equals 0. Does that count if x is 0?
So you plugged in a number?
No, I did the same that you did right there, but my thing came out as x equals 0.
Okay, so it should not, because technically your x cancels out. If you get x equals 0, which means you have one x left behind. So yeah, your x should cancel out and basically become a 0. Okay? What are we saying about 5? So we've got identity, which means you should be having either inconsistent or a conditional equation. Yeah.
So I got x equals 9, which is conditional.
Okay, so you actually did get an answer. Okay. That should make it conditional then. So this guy is 2 times plus 3 plus x minus 1. So again, same thing, distribute that number inside the parentheses. 2x plus 6, 3x minus 3.
So
So-
how come how come on the left side it's +6, on the right side it's -3?
Oh,
Why don't you switch your,
no, because right now I'm just multiplying that 2, right, inside my parentheses.
okay.
So it was the 2 times positive 3, which gives
Oh,
positive
okay.
6, and 3 times negative
Is
1.
it negative? Okay.
Yeah, so right now we haven't moved anything, we're
Okay.
just multiplying the numbers on the outside. Yeah. So the one thing you should actually notice is that our x has different coefficients, right? One of them is 2x, the other is 3x. So that's usually a good sign that they're not going to cancel each other out, right? With the previous example, we had same 3x and 3x on both sides. So when you move them, they cancel each other out. So in this case, it's a good sign that we have 2 different coefficients on our x, which means we will actually have an x left behind. Sometimes that doesn't work because you could have another x lingering somewhere, which is not the case here. So I'm actually starting by moving my x terms. These guys cancel out, leaving us behind with a 6 on this side. 3 minus 2, of course, gives you 1, so that's just an x minus 3. And then when you move that 3 to the other side, you get your 9. So let's add that 3 and Those guys are gone. So if you're getting one single answer, Herbert, right? So as you mentioned, it's going to be a conditional if you come up with an answer. So this is conditional. Process of elimination, what should number 6 be then? Inconsistent, right? Because that's the only one left. But let's verify that just to be sure. So obviously you can notice number 4 and number 6 are very similar. The only exception is here we had a negative 18, here we have a positive 18, and that's actually what is going to change that for us and give us an inconsistent equation here. So very quickly, let's look at that guy. Then start by distributing that 3 inside the parentheses. So again, we'll get a negative 18 from here. So you can see again, as I was mentioning, our x is the same value, right? 3x and 3x, they're both positive 3x. So as soon as I move one of them, they're going to end up canceling out. But since we actually have different signs on our 18, that's why we're not going to get an identity. So our x's will cancel out, leaving us behind with negative 18 here and positive 18 there, right? So 2 different signs. That means we actually have a false statement. They're not the same number. And this is where it becomes an inconsistent equation instead of identity. So if you get a true statement when you solve it, that's an identity. If you actually get an answer for x, like we did for x equals 9, that's conditional. If you get a false statement, that's what makes it an inconsistent equation. Okay. Questions on any of these 3 examples? And you know, of course, this will be true for any type of equation you work with. This is not just for linear equations. This will apply to quadratics or polynomials, anything. Okay, so the next type of equations we're getting into is rational expressions. Here, basically, when we're saying rational expressions, that basically means you can have rational numbers or fractions in your equation. And rational expression basically means that your numerator and or denominator can have polynomials in them, can be an expression. So one of the key things to remember here, as you will notice in this first example, our variable w is in the denominator. Anytime your variable ends up in the denominator, we're going to have to run into this problem that division by 0 is undefined, and there's going to be at least one or more than one number which will make our denominator 0, which means we cannot use that as part of our solution set. So we will need to remember to exclude those numbers which make our denominator 0. Okay? So as your instructions say, start by multiplying your entire equation by the least common denominator. And the idea here is kind of like I showed you in number 2. If you multiply your entire equation by the least common denominator, you get rid of your fraction. And it makes solving a lot easier. But I know, again, depending on how you guys saw these problems, some of you do have different techniques which works equally well. So if you're comfortable with a certain way of solving it, I'm okay with you guys doing it that way. Again, we will need to remember to check our answers, because for any reason, one of the answers we get, which happens to make our denominator 0, we'll need to remember to keep it out of our solution set. So let's start with this guy. Can you tell me what our LCD, least common denominator, for this equation should be? W minus 1. There's got to be another one with that. if we try to simplify this 2w minus 2, what will that be? How can I simplify that expression 2w minus 2? Is there anything common between those two terms? A 2, right? So we can actually take a 2 on the outside. So if I'm taking this 2 out, I'm just left with the w here. Minus 2 goes into itself 1 time. So you can actually factor that expression, which is the same thing here. So these guys factor into 2 times w minus 1. And of course, you can see we have a w minus 1 from here. So when you talk about finding your least common denominator, all of these 3 denominators have a w minus 1, so we definitely need to take that into account. But since I also have this 2 here, that also goes with our least common denominator, right? So w minus 1 and 2 together make your least common denominator.
Since it's the least common denominator, it would be the smallest one of them all.
Yeah, you would think that because of the word least, but least basically means that you are taking, so w minus 1 is common to all of them, right? So you basically just write that down once. And then whatever was not common to all 3, you still need to include that. So when we're talking about least common denominator, and you know you guys did, Levi, were you in my class? Are you in 093?
Yeah.
You're not in the lab, you're just in the
Just
course. Yeah, so we talked about this last time, last class 093, where we did the GCF and the LCMs. So when you're talking about the least common denominator, you're saying out of all the common denominators, what's the smallest number? So think about denominators 2 and 3, right? When I multiply 2 times 3, I get 6. So 6 is going to be my least common denominator, but 2 and 3 both go into 12 also, right? So technically 12 can also be a common denominator. 18, 24, 30, right? Any of those multiples will be common denominators, but out of the common denominators, which is the least, which is a 6, right? So that's actually what we mean by least.
So if we do it that way, then technically we would have to take 1 over w negative 1, and we'd have to make that 2 over 2.
To find the common, yeah. And so that's kind of where how you do it will change. So if you're used to keeping and just multiplying the first one by 2, so that all my denominators match, you can do that. But I actually like to get rid of my denominators completely, kind of like what I showed you in number 2. So we're actually going to repeat that process here. So I'm going to take my entire equation, and let's change our color here. So I'm going to take my entire equation and I'm going to multiply it by this LCD. So that's going to be every term. So multiply every term with that common denominator. So 2 parentheses w minus 1 is my LCD. I am multiplying that with my first term, which is 1 over w minus 1 minus, again, my LCD, 2 times w minus 1 multiplied with 1 over. Instead of writing it in the original form, I'm going to write it in the factored form so it's easy for us to cancel things out. So 2 times w minus 1 here equal to, again, my LCD, 2 times w minus 1 and multiplied by our expression 1 over 2 times w minus 1. So I'm taking that LCD and multiplying it with each single term of our equation. On the first part, only the w minus 1 cancels out. So you will end up multiplying 2 times 1, which will give us 2 down here. For the other expressions, you will actually cancel out the 2 and the w minus 1, right? Both of them will cancel. So 2 and w minus 1. So all our denominators should cancel out. And then we're doing 2 times 1, which is 2, minus everything canceled out, so I'm just left with the 1 from here, equals, again, everything canceled out, so I'm just left with the 1 over there. So 2 minus 1 is 1, 1 equals 1. This is a true statement. So what will our solution set look like for this problem? Can I use all real numbers, or will I have any restriction?
The restriction would be 1, wouldn't it be? That
Yeah.
makes the denominator 0.
Very good. So 1 makes our denominator 0, right? Because the moment I put a 1 in here, 1 minus 1 is 0. I put a 1 in here, 2 minus 2 is 0. 2 minus 2 is 0. So let me actually show you how we're going to write this one down. So we're going to use this notation where we're basically saying the solution set can be every real number except we cannot use 1 in our case, right? So
My answer was 1 over W minus 1, or W negative 1, and well, never mind, that's the same. So 1 over W negative 1, 1 subtract 1 W negative 1, which is 0, so 0 equals 0.
oh, okay, so yeah, you're still ending up with a true statement then, right? Yeah, and that's what's happening because you will notice that W did not make it all the way to the end, right? Once we canceled out with our least common denominator, your W actually disappears. So that only meant 2 things if the W disappears. You're either going to have an identity or an inconsistent equation. And since we're getting a true statement, we know this is an identity with the exception that our W cannot be 1. Okay, so it can be all real numbers except 1.
So in this case, it would also be considered identity and not a conditional.
Exactly, yeah. Alrighty, let's look at our next example. Number 8. So you've got t over t plus 3 plus 4 equals 2 over t plus 3. So if it helps, you can actually write the number 4 as 4 over 1 to give yourself a denominator so that it makes it easier for you to decide what the least common denominator should be. So you should have t plus 3, and then think of that as a 1 for your denominator. So what do you think that least common denominator should be?
I have a question.
Yeah, sure.
Since I know the last one we used the 2 as well as the least common, but would we have to use this one since it's just the 1?
So 1 times a number is a number itself, right? So you don't really specifically need to write down the
Oh,
one.
so then
Yeah.
it would just be 2 plus 3.
Very good. Yeah, your least common denominator is just going to be 2 plus 3. And you can kind of see what happens when we multiply everything by t plus 3, right? Because these guys will cancel out, but then we will actually have a t remaining here. So this one hopefully will give us a different answer than the previous example. So we're multiplying the 4 equation again by t plus 3. Okay, so that's the LCD with the first term plus our LCD again with the second term. That should be equal to our LCD with the last term. I'm just putting the LCD in parentheses so we know they are one expression. So like I said, the first one, t plus 3 and t plus 3 will cancel out. The last one, t plus 3 and t plus 3 will cancel out. From our first term, the denominator canceled out, so you're only left behind with that t. Plus, I have 4 times the t plus 3. For now, I'm actually just going to leave it as it is. If you guys want to distribute at this stage and then write the answer, that's fine. On the other side of the equal to, again, our t plus 3 cancels out, so it just left us behind with that 2 from the numerator. Now, I'm ready to distribute this 4 inside my parentheses. So t plus 4 times t is 4t, plus 4 times 3 is 12, equals 2. Go ahead, clean it up, and let me see what answer you're getting for t. You have an answer?
Yeah,
Yeah? What'd you think?
I got t equals 5.
T equals 5, okay. Brandy? T equals -2. T equals -2. Okay, so 5 and -2. What else are we getting?
I got -2.
You got -2? Okay, so you may want to check because I'm getting 3 people with -2 as the answer. So see what happens. Okay, so obviously combine your like terms to get the 2 t terms together. 4 plus 1 will give you 5t, and then we're subtracting the 12. These will give you
Shut down. I can't math.
-10. You figure out?
Yeah,
Yeah.
I
Okay.
didn't do math right.
You didn't do the math right on. Okay. Okay. Divide both sides by 5, and of course, that's where you're getting your -2 from. So what kind of equation does that make this? Yeah, very good. Makes it a conditional equation, and then of course we're getting only one single answer. Now the question is this answer going to make our denominator 0?
What was the question?
Will -2 make our denominator a 0?
No.
No, because when we put -2 in for t, -2 plus 3 will give us +1, right? So that means that's safe answer to use. What should my t value have been if I was going to get a 0 at the bottom? -3, yeah, because -3 and +3 would make my denominator a 0. So as long as I don't have a -3 in there, we're actually safe. So make sure you check for the denominator when you write these answers down. I cannot spell today.
What is, I don't know why, but I did it completely different. Came up with the same answer. But what is it called when you take the least common denominator and you put it off to the right and you add it as, not add it, but you,
Are you keeping your fractions?
yes. Because I'm breaking it down completely different.
You just want to try this side. minus 2, and then you trigger to the other side. So yeah, I mean, you're still following the same process with the exception you did not get rid of the denominator, which is okay. Like I said, you don't have to. This is just my preference because once I'm done with the denominators, I don't have to keep worrying about, finding the common denominator. So you are fine. What you did is mathematically absolutely correct. Yeah.
What's gonna be more,
As long as your math is good,
what's gonna be more time effective?
the one you're easiest working with. So it sounds like you are more comfortable doing it that way because you did the same thing for number 2 also, right? So I would say stick to what you know. Because if you try to change it, you might get confused in my method. So you're getting the right answer.
I mean, that makes total sense. I just,
Yeah, but you're still getting the right answer, right? Which means you have that down perfectly. But if you want to try it this way, I'm okay with it. If you stay with that, I'm okay with it. Because, I'm not looking for a method. I am looking for, did you do your math correctly? And did you get to the right answer? So if you use a different method from mine, I'm really okay with it. Yeah, so if you want to try it both ways and then see which works for you, go that way. But it sounds like you have that down already, honestly. If you were getting the wrong answer, then I'd probably say, okay, forget about that method.
Did you? Apparently it's working. I'm getting confused because I used to go,
That way?
but now I'm trying, like it's confusing me because you're teaching this way, which is fine.
Yeah.
I'm getting this now, but
I would again say the same thing for you. If you have that method down and you're comfortable with
this
it,
seems easier though.
this seems
But
easier.
I'm just getting
See,
confused
it's
trying
just,
to.
yeah, I am just so used to getting rid of my denominators because I don't know why. It may just be
It makes it
something I
easier.
learned as a kid or something, but I have always gotten rid of my denominators.
I've always done that, but just now, see.
Because now I have students who do kind of like what you did. They'll start out that way, but then their math changes. So a lot of times they'll do fraction with a fraction and then integer with an integer and then try to bring the two together. So everybody has a whole different approach because, it just depends how you saw it in school and how you got used to doing it. So if it's confusing you, I would say again, same thing as I told him. Pick one method, at least do a couple examples with that, see if you're comfortable with it. So let's say you start with mine and that you don't like it, then go back to the way you were doing it. Yeah? So try it both ways. And again, if you need my help, we can definitely work on it together also. Thank you. All right, wonderful. Any other questions about this guy? Number 8 or whatever this was. Okay, number 9, you guys are doing on your own. So bring me the answers. Well, I guess we're meeting next Wednesday because Monday is a holiday. So bring me the answers on Wednesday. So that was equations involving rational expressions. Now we're getting into absolute value equations. So absolute value equations. First, we need to know what is an absolute value. So what do you understand by absolute value?
It's a,
The distance from 0.
Distance from 0. Very good. So what does that really mean? When I look at x equals -5 or absolute value of x equals -5, why does that become a +5?
But you can't have a negative distance from 0. It's always going to be a positive.
Yeah, because just think about in everyday life, when we think about distances, don't we always talk about distances as being a positive distance, right? I mean, if you're going north, you wouldn't say, oh, I don't know how far Greeley is from here.
30 miles.
30 miles, sure, I'll take it. So I would say I'm going 30 miles north, right? If I was going down to Denver, Denver would be what, 20, 25?
Yeah.
Somewhere in there. I wouldn't really say I'm going -25 miles to Denver, right? We may say south, or we would just say I'm going down to Denver. So if you think about distances, we never use a positive or a negative value with the distance. We just say, 25 miles south or 30 miles north. It's the same thing here when we're talking about a distance from 0 on the number line. So if I'm looking at, okay, so think of me as 0. This is the positive side, my left is the negative side. So if I'm looking at -5, it's basically 5 units from 0, right? So we would say that's a distance of 5. If I was looking at +4 On the right-hand side, we would say, okay, from 0, it's 4 units away, but it would still be just a distance of 4 or a distance of 5. So whenever we think about absolute value, we always think about absolute value becoming a positive number because they are always distances from 0. So if your x was positive 3 to begin with, we're saying the distance of 3 is 3 from 0, right? If you are looking at x as being negative 3, well, the distance of negative 3 from 0 is 3 units. Now, what this little definition here is talking about, so when we're saying absolute value of x equals x, if your x happens to be 0 or a positive number, and we're saying absolute value of x happens to be negative x, if x to begin with is a negative number. So the idea is, for this first part, let's do this here. So if we're saying x equals 4, right? So that's a number which is greater than 0. So by definition, from the absolute value function, we are saying absolute value of 4 is going to be 4. That's a distance from 0. So again, if I look at this on the number line, here's my 0, here's my 4, and we're saying starting from 0, this distance here is 4 units, right? So that's why it's 4. But now, if I'm talking about this negative side, and let's say x is negative 5. So by definition of absolute value, that actually means we are bringing in a negative sign, and then the negative from the number itself, 2 negatives, ends up giving us a positive value. So this is basically again saying from 0 to negative 5, what is that distance? And again, that's going to be a distance of 5 units. So this is how we actually define the absolute value function. If your x values are positive, the x will stay the same. If your x values to begin with are negative, we bring in that extra negative sign, so the 2 negatives end up giving you a positive. So this is just the formal definition of how we define absolute value functions. So here the idea is, if you have absolute value of x equals any number k, and k is a positive number, so you can have k equals 1, 2, 3, up to positive infinity, even decimals for that matter, you're actually going to split up your absolute value equation in 2 parts. Once with a negative k, once with a positive k, and you will end up actually getting 2 different answers. If your equation is set up as absolute value of x equals 0, then in that case, you're actually only going to end up getting 1 answer. You don't get 2 answers in that case. If your absolute value of x is equal to negative 5, you actually cannot solve that equation because your distance cannot be a negative number. So your absolute value equations can be given to you in 3 forms. You can have the absolute value equal a positive number, which is then where we get 2 answers from. You can have your absolute value equal to 0, which will only give you 1 answer. Now, if your absolute value is equal to a negative number to begin with, you cannot solve that because distances cannot be negative, so you will have no solution for this 3rd type. So this is the first type. Second type, which actually is not really actually a second type, and this one will also give you a different answer. So we're giving you 3 different examples to show you how that absolute value problem can look like. Okay, so let's start with the first one. This is number 10. So you are given absolute value of x minus 4 equals 8. So remember, this is the first type of equation. So the way you set this up is in two parts. Start with your x minus 4 equals 8. So the only difference is now we're not putting those absolute value symbols on, okay? That's the first setup. Or for the second one, again, we will have our x minus 4, but instead of positive 8, you actually change it to negative 8. Now, why do we need to do that? Why are we saying it can be equal to positive 8 or it can be equal to negative 8? So we are saying,
both answers.
sorry?
You need both answers?
We do need both answers because think about it. We are saying whatever the number on the inside is, we don't know what it is because we haven't solved it. But they're saying whatever the number you have here has a distance of 8. Well, think about it. I can get that distance of 8 on both sides of 0 because I can get a distance of 8 from here. I can get a distance of 8 from here. Now, we don't know where that x falls, right? Because this is just us trying to come up with an answer. So your x could be on this side, but your x could also be on the other side. So both sides give us that distance of 8. So when we're doing this calculation, we need to figure out what that x could be because either way, we'll get that distance. So with the first part, what do you get for x? 12. So move that 4 to the other side, you add 4. 8 plus 4 gives you 12. So basically we're saying if your x is 12, 12 minus 4 will still end up giving us a distance of 8. Or what happens here? So negative 4 means somewhere halfway here, negative 4 minus 4 will also give us a distance of 8. So x could be either of those numbers. So your solution set, again, we use those brackets here, will be negative 4 or 12.
I have a question. So in the assignment, would it matter which that I put first in my answer? Like if I did the 12 and then the minus 4?
Oh yeah, no, it wouldn't matter. I mean, normally we're used to putting the smaller number first, then the larger number, but my math plan has no restriction.
Okay.
So even if you did 12 comma, negative
Okay.
4, yeah, you're fine.
Okay.
Anybody have any other question on this? Okay, so like I said, if you have a positive number on the other side, excuse me, from your absolute value, this will be your general setup. Once with the positive number, once with the negative number, and you should get 2 answers from it. Now let's look at the other variations for this problem. So you will notice here that my absolute value is not by itself, right? The absolute value is being multiplied by 2 in the front, and then we also have this minus 10 at the back. So the first thing you are doing when you're working with these absolute value equations, and that's going to be the same thing for number 12, is isolate the absolute value, which means take all the things that are around it and move it. Kind of like how we would isolate an x, using that same idea, but this time we're isolating the absolute value. So whatever's on the inside. So the first thing we're actually going to do is take the 10 over to the other side and then get rid of this 2. Once I isolate my absolute value, then I can solve this equation. Okay, so let's see how we can do that. Like I said, start by moving the 10 over. So since it's plus 10, minus 10, we'll add 10 to both sides. So 0 plus 10 will of course become a 10. And what do we do with the 2?
Subtract it or do we distribute?
So we cannot distribute within an absolute value symbol, parentheses, yes, but not absolute value.
So would you divide it?
You would actually need to divide it because even though these are not parentheses, you are technically still multiplying that too, right? Because there's no plus or minus sign in the middle,
So it's 2x.
which means it's multiplication. So yeah, you need to divide to get rid of it. Not here. So we divide both sides by 2. And absolute value of x plus 5 equals 5. So with absolute value, we do not distribute the number from the outside. Parentheses, brackets, yes, not with the absolute value symbol. Now, once you get this, we're basically back to what our previous example looked like. So now we're ready to split it up into 2 parts. So this is where you will do x plus 5 equals positive 5, or x plus 5 equals negative 5, and that's how we'll get our 2 different answers for this one. And what will those answers be?
0 and negative
0 and negative 10, I believe you're right.
Yep.
So we start by subtracting. And actually, positive 5 and negative 5 will cancel out. This is where we get our 0 from. Or we're still subtracting 5. But here, you've got negative 5 minus 5, which is your negative 10. All righty, very good.
You always have to write solutions, but you can't just do this.
Oh, you don't have to in my
Okay.
math lab. Yeah. Because they'll actually, I believe they also give you the brackets, right? You just actually just type it in.
If I was
numbers
doing
in.
it by hand, would I have to write solutions to that? Or
No.
is that what those brackets mean?
That's what the brackets mean, yeah. Okay, questions on this guy? 11.
So just so I'm clear,
Sure.
if we write out a problem, every single answer that we do there is a solution, so we have to put this parentheses around, right? So we know what we're at.
So what those answers are. Yeah, so in this case, you should get 2 answers, not more than that. What do you guys think happens on number 12? Where would you start on number 12?
Adding the 2.
You'd get the 3 on the right hand side.
Before the 3.
I would add the 5 and the 3.
No,
Subtract
you
5.
cannot, because what's happening with the 3?
I don't know, I would guess that.
No, that's fine, and I'm glad you said that, because in case just anybody else was thinking, it's good to
Oh, it's
clarify that.
3x.
Yeah, the 3 is actually the same as the 2 here. It's being multiplied into your absolute value. So this is actually that 10 that you had at the end. So you will start by moving the 5 to the other side first and then dividing by 3. Because the 3 is not independent. It's being multiplied with the absolute value, so that's why you cannot add the 5 and the 3. Okay, so I'll give you a couple minutes. Let me see what answer you come up with. You done already? Yeah. Okay, very good.
So would you
So now what do you think we can do from here on? Go ahead.
keep it as negative 5 first?
Yeah.
You don't have to simplify it.
So you've got your absolute value on one side.
Yeah, so x equals 4, absolute value, negative 5.
Over 3. Okay. Now what do we do after that?
Make a positive.
How?
X minus 4. I have a question.
Yeah, sure.
Since the 5 is a negative, does it make the whole fraction a negative or just the 5?
Technically, it makes a whole fraction. Yeah. So you are ending up with absolute value of x minus 4 equals negative 5 over 3. Everybody?
Why is it negative?
Because when you move the 5, it's positive on this side, right? So when you move it, it becomes negative. So that's where that negative sign is coming from.
Do we have to make it a common denominator?
We have to make it a common denominator for what?
When we drop down x minus 4 to make it equal out negative 5/3.
No. You don't need to do that. Okay, so think about this. Absolute value is a distance from 0. What kind of distance will give you negative 5 over 3? What distance is negative 5/3? Can distance be negative? No. Distance cannot be negative, and this is what you guys really need to remember. When you have absolute value equals a negative number, there is no solution, right? Because distance cannot be negative. Distance can be 0. That basically means you're still at the starting point, right? You haven't moved. Distance can be positive, but distance cannot be negative. So actually, you cannot go any further than that. If this guy had ended up being a positive number, we could have done our little setup with the 2 different equations, but because it's saying absolute value is equal to a negative number, we don't have an answer. There is no solution. Or you can use the symbol, which is a symbol for an empty set. Okay? No solution to this problem.
Would we put those brackets around that last
No,
answer?
for the empty set, you don't use the brackets. If you want to use the brackets, then it's actually just brackets with nothing inside of it. Because you're denoting that it's an empty set, there are no answers in there. And I'm actually not sure how my math lab does it. It may actually give you a bullet point where you choose no solution, or it gives you the symbol. I'm not really sure about that. You may have to just kind of play around with that. All right, so keep in mind, you will see examples like this in your homework, your quiz, and it can also show up on your exam. So just be very careful about the absolute value and having a negative on the other side, like number 12. All right, guys, our last example for this section is just looking at an application. So we will definitely use a given equation in this case, but a lot of times as we move forward in this course, we will actually try to come up with equations on our own. So this is just to get us started. We are saying that if X represents the number of years since 1990, and Y is the median income in dollars for working women in the US, then using this equation, which models the data, they want to know in what year will the median income for the women be $25,000. So we're basically using this model to make a prediction of when the median income will be 25K. So let's start by writing down our model. So that's Y equals 355.9x plus 11,075.3. Now, X is the number of years since 1990, and Y is the median income. In dollars. So they want to know in what year will the median income be $25,000. So what do we do to solve this problem?
You said that equation equal to 25.
For the Y, right? Because they're saying the median income will be 25,000, which is the Y variable, which means you'd replace the Y with your $25,000 and you're working backwards to find your X. So $25,000. And then the whole equation on the right-hand side. So let me see what answers you come up with. And they're asking us to round it to the nearest year, so kind of keep that in mind also. So remember, they're not asking you for the number of years. They're asking you in what year. So they actually want the actual year. So you will need to calculate that after you come up with your value of X. Does anybody have an answer? In what year? Yes?
2025?
2025. You're short. It should be after that.
So then you're solving for y. How do you?
You're not solving for y. You're actually given the value for y, which is your $25,000, right? Because that's your median income.
Right.
2049.
So. I'm confused. They got 30.12
So
for that.
you subtract it down. That's the answer. I would check that number one more time. Oh, that's not really, that's 13,000 something. 9, and then what did you do after
And you put it, and then we divided the
that? Okay.
355.9.
Okay, so that's telling you how many years it's going to take. But now we want to figure out what is the actual year. So if you start counting from 1990, where will that put you at?
1990 plus 39.
Yes,
Gotcha.
essentially, yeah. Okay,
So it'd be 2029.
there you go. All right, so we're again trying to isolate our x just like we were solving equations. So start by subtracting that 11,075.3 value, which ends up giving you 13,924.7 equals 355.9x, right? And now to get x by itself, since we're multiplying by 355.9, we divide both sides. leaves us with x on the right-hand side, and then whatever this answer comes out to be. That number keeps going. Now, if you look at your instructions, they want to know to the nearest year, right? So since this is 3.1, that means you just 39.1, you're just keeping the number of years at 39, right? So use your rounding rules. If this was 0.5, we would have bumped this up to 40. But since it's less than 0.5, we're just keeping it at approximately 39 years. So then to figure out in what year the median income will be 25,000, you're starting your X values at 1990, right? They're telling you that if X is the number of years after 1990, so that means that's your starting point. You're taking 1990 and adding your 39 years to that, which gives you the year 2029. Is the year in which median income for women will be $25,000. Now, when we're talking about median, we're talking about average. So, I mean, think about it. 2029, that's another, well, at least 9 years or 10 years from now, the median income will be $25,000. So, you know, just not that it's part of our class discussion, but it is an interesting thing to think about, that the gap between salaries, pay scale is really, really significantly huge. If we're talking about in the future, the median income will be just $25,000, which is not even living wages, right? I mean, especially not in a place like Colorado. So that's, yeah, pretty scary to think about. But like I said, in this example, they gave us the equation that we could use, but as we move forward, we'll be trying to come up with our own equations which would satisfy our problem anyways. So do you have any questions on what we did here in section 1? Now remember, this problem you guys are going to try and do on your own. One word I would like to tell you is start by factoring this expression. Once you factor it, it will be easy for you to figure out what your least common denominator.
I don't really have a question, but for me, I'm kind of having a hard time following. I like to see what we need to do, and then I like to try and figure it out a few times so I can master it.
Yeah.
But right now, I feel like I'm learning so much. Like I'm trying to apply each technique to the next question. And I get confused.
No, it's not, because we are changing topics, right? So we went from linear equations in the first part to equations involving
Right. I just feel
rational
like I'm not
expressions.
mastering each level before I'm moving. So it's just kind of confusing.
Yeah, and so, you know, that's unfortunately just the setup of this class, is because they have honestly put a lot of required material in this course that we have to try and cover, because anything that's recommended I can leave out, but anything that's required I have to go. So this class, and I know some of you have taken this course before, this class literally goes from topic to topic to topic, because, you know, they give us an hour, 40 minutes.
Right, and I understand.
So I do feel bad for you, and I completely understand what you're saying. And that's why, if you want to see me outside of class, so the ones that like you're feeling like, okay, we're going, you know, you're not able to master a given topic and we're just moving from one topic to the other, we can definitely do more examples. But unfortunately, I cannot take too much of.
If I had the hardback
Class.
book, could I follow it that way?
Say that one more time.
If I actually had the paper book, could I follow it that way?
You would be able to see the examples in there. Other than that, there's not really going to be anything very different.
But it'll let me work out a few.
But you will get to see examples, because I haven't included any examples in your
That
hand.
would help me.
So that might help you. And then I would also say practicing with your homework.
I think I'm gonna forget.
By the time you get to your
I'm
homework.
gonna start confusing.
Okay.
My math
So I
lab-
would say try it. If
My
you
math
think.
lab has this section on there to where you can try it. And if you don't get it, you just try it again and try it again and try it again and try it again.
On
So
my
you
math
can-
lab
you can
also, on
practice
top right
on
of
there.
each question, it has how to do it. So like, I'll click on it and show you the steps to do it.
Yeah, like my last math class, we used my math lab.
Okay.
I hated math. That class I actually liked a lot just because it makes it so much easier to practice
Okay.
with my athletics.
I know I'm gonna forget.
Yeah, and then keep in mind, I showed you guys last time, you have the study plan option that I have added, which is not for grade at all. So you can go mess up in study plan as much as you like, and it will not affect your grade. Because I'm not using the study plan for a grade. Literally, that's only there. If you have 100% on your grade homework and you don't want to mess with it, you can go to the study plan and just practice till your heart's content, because it will not affect you.
That's what I'm missing out, that practice.
Yeah, so you can definitely get a lot of practice from study plan, because I know one problem you change in your homework, it just brings your grade up or down depending on how you did. So if you don't want to mess with your homework grade at all, use the study plan. Okay, but yeah, I know I think you are going to feel a little bit of that where we